Recently, the National Oceanic and Atmospheric Administration's NOAA Space Weather Prediction Center issued a G4 geomagnetic storm alert. This was due to at least 7 coronal mass ejections, CMEs, from the Sun. These CMEs can trigger geomagnetic storms, solar storms, that reach Earth, resulting in issues such as radio interference and satellite disruptions. Solar storms are classified into 5 levels, from G1 to G5. Luckily, this solar storm concluded without causing significant damage, only creating some stunning auroras around the world. Today, we will delve into the principles and history of solar storms. Solar storms, auroras, and their impact on the ionosphere. Just as the Earth rotates, spins on its own, so does the Sun. Just as Earth has a magnetic field, a space with magnetic lines of force that have an attractive or repulsive force, there are magnetic lines of force around the Sun that create numerous magnetic fields. However, unlike the Earth, the Sun rotates at different speeds in different areas, causing these magnetic lines to twist and tangle. Where these lines are most twisted, the temperature is cooler, making these regions appear darker. These dark, heavily kinked areas are known as sunspots. Sunspots are areas of strong magnetic field activity that are cooler in temperature than their surroundings, but they instantaneously radiate energy outward. This is a solar storm that causes a space weather event called a coronal mass ejection, or flare. On an 11-year cycle, when sunspots become very bright or numerous, these events occur and have a major impact on Earth. This is because high-energy particles, such as electrons and protons, are ejected from the Sun in the form of plasma, which is then pushed all the way to Earth. High-energy particles that reach Earth in coronal mass ejections disrupt communications but appear as auroras at the poles. In particular, during peak sunspot activity, high-energy particles from space collide with oxygen, O2, molecules over the polar regions, and light is produced by an electrical discharge, electricity phenomenon. However, the aurora borealis, which is only seen in the polar regions, has been spotted in the US and Latin America, including Florida, Cuba, and Colombia, and has paralyzed computers. The Carrington event, recognized as the worst solar storm in history, caused widespread effects. Since then, there has been extensive study of solar storms and high-energy particle activity, particularly as society's dependence on electricity and electronics has grown.